The next unit of trimester 3 will be weather. Learning target 1 for weather is I know air pressure is caused by the mass of air and is affected by temperature. Your essential vocabulary is air pressure and temperature. Air mass. What is it? You do not need to know the certain types of air masses. However, you do need to know what an air mass is. An air mass is a large body of air with a particular temperature, pressure, and humidity. Notice that the air masses above water are considered moist, and the air masses closer to the equator are warmer. Also remember the last unit when we discussed the amount of water vapor is more above oceans. Based on the information presented, you should be able to explain why the maritime tropical air mass is warm and moist, and the continental polar air mass is cold and dry. Pause the video if necessary to look at the picture. Temperature. Remember what happens when the temperature of gases or liquids change? As gases or liquids cool, the molecules slow down and move closer together. Think, I'm cold. As the molecules heat up, they speed up, bounce into each other, and spread apart. Also remember the difference between cold air and warm air behavior. The gas molecules closest to the Earth's surface are packed closely together because air has mass and is made of molecules. This means that as hot air rises, it becomes less dense and has less pressure. Low pressure is represented by a red L. Now for cold air sinks because it is more dense and then because it is more dense, it has more pressure. High pressure is represented by a blue H. Important thing to consider is do not get confused. H does not represent hot. It represents high pressure. Learning target 2 for weather. I can explain how differences in temperature and air pressure cause winds. Your essential vocabulary is global winds, prevailing westerlies, local winds, land breeze, sea breeze, and Coriolis effect. Wind is caused by air flowing from high pressure to low pressure. Since the Earth is rotating, however, the air does not flow directly from high to low pressure, but it is deflected to the right in the northern hemisphere and to the left in the southern hemisphere, so that the wind flows mostly around the high and low pressure areas. The closer the high and low pressure areas are together, the stronger the pressure gradient and the stronger the winds. Winds can be thought of one way that the atmosphere moves excess heat around. Directly or indirectly, winds form for the primary purpose of helping to transport excess heat either away from the surface of the Earth, where the sunlight causes an excess of energy buildup, or from warm regions, like the tropics, to cooler regions, usually in higher latitudes, like the northern Canada or the North or South Poles. Types of wind. There are two types of wind. There are global winds, which impact the entire Earth, and local winds, which are, well, local. Winds are named by the direction from which they blow. So again, winds are named by the direction from which they blow. So the globe is enriched by 6 major wind belts, 3 in each hemisphere. From the pole to the equator, they are the polar easterlies, the westerlies, and the trade winds. The types of winds that influence weather in the United States are the prevailing westerlies. These are the global winds that you're going to need to know. The westerlies blow from west from the west, tending somewhat toward the north. This causes most of the weather in the United States to move from west to east, or from California to, say, New York. So look at the picture on the left. We're still talking about global winds here. So winds blow across the earth from high pressure systems to low pressure systems. However, winds don't travel in a straight line. The actual path of the winds and of ocean currents, which are pushed by wind, are partly a result of what's called the Coriolis effect. The Coriolis effect is named after Gustave Coriolis, the 19th century French mathematician who first explained it. The key to the Coriolis effect lies in the Earth's rotation. The Earth rotates faster at the equator than it does at the poles. This is because the Earth is wider at the equator. A point on the equator has farther to travel in a day. Let's pretend you're standing at the equator and you want to throw a ball to your friend in the middle of North America. If you throw the ball in a straight line, it'll appear to land to the right of your friend because he's moving slower and has not caught up. Now let's pretend you're standing at the North Pole. When you throw the ball to your friend, it'll again appear to land to the right of him, but this time it's because he's moving faster than you are and has moved ahead of the ball. Now look at the picture in the lower right. See how it looks like the ball is curving back towards her. Actually, when she throws the ball is actually traveling in a straight line. However, because of the rotation of the merry-go-round, it appears that the ball is curving. Now let's talk about local winds. Local winds are small-scale convection-type winds of local origin caused by temperature differences. Local terrain, such as hills, oceans, has a very strong influence on local winds, and the more varied the terrain, the greater the influence. There are two types of local winds we will learn about. They are sea breeze and land breeze. Remember, the type of breeze is due to where the wind comes from. So, sea breeze comes from the sea, and land breeze comes from the land. In the previous unit, we discussed how the sun caused land surfaces to become warmer than water surfaces during the daytime. As a result of this local scale temperature and pressure difference, a sea breeze begins to flow inland from over the water, forcing warm air over the land to rise and then cool. In the absence of strong general winds, this air flows seaward to replace air which has settled and moved towards the shore and thus completes the circulation cell. The surface breeze the surface sea breeze begins around mid-morning, strengthens during the day because of the warming sun, and ends around sunset. Here is another look at a sea breeze. The land breeze at night is the reverse of the daytime sea breeze circulation. At night, the land surfaces cool more quickly than water surfaces. Air in contact with the land then becomes cooler than air over adjacent water. Again, a difference in air pressure develops over the land, and the water causing air to flow from the land to the water. The air must be replaced, but return flow from the sky is likely to be weak and diffuse and is diminished in the prevailing general winds. The land breeze begins 2 to 3 hours after sunset and usually ends shortly after sunrise. Here's another look at the land breeze.